Hello Math 125 fans. In this video I'm going to talk through the winter 2023 final. I'm going to try something a little different in that I am going to, in addition to sort of talking about how you would start the problems and looking at the solutions, I've pulled up a few examples of mistakes. I just grabbed a couple examples of mistakes students made. I don't know if that will add to this at all. It's just something I'm trying. Let me know if you find this to be helpful. So this is winter 2023. The structures of the finals are pretty similar from quarter to quarter, not always exactly the same. But let's look at the first question. So usually the first couple pages of the exams are integration. This is a trig integral. So trig integrals, if you remember, so just a quick review, that there really were two scenarios, and the two scenarios were substitution or half angle. And half angle was only in the situation where it was sine and cosine and only even powers. So that's not this. So I know it's going to be substitution. This one's a substitution that involves secant and tangent. I tried to give you a way to remember. So the moment you see it involves secant and tangent, you're going to be doing one of two things. You're either going to have u equals tangent, or you're going to have u equals secant. And which way works depends on the derivative. If you're going to be using secant, then you have to pull out a secant tangent. And if you're going to be using tangent, you're going to pull out a secant squared. And you should remember that after you pull out, you're hoping you have even powers. So pulling this out will not make this even. It'll be a 5. So that rules that out. But you could also just have in your note sheet, odd, secant, do this. But anyways, I'm going to set up this substitution, which means the first step I'm going to do is I'm going to write secant, tangent, dx. Again, on your note sheet, you could say, okay, it's odd. That's what I'm going to do. And then I'm going to try to turn everything else into a secant so that this substitution works. There's going to be a secant to the 6th. So that's already a secant. And there's going to be a tangent to the 4th. So here's the challenge. What do we do with the tangent to the 4th? And that's what we have to remember. That tangent squared is secant squared minus 1. Now it's to the 4th, so there's tangent squared times tangent squared. So it's tangent. So anyways, you're going to have a secant squared of x minus 1 squared, or however you want to write it. And a secant to the 6th of x, and then this thing. But the whole point of all that is now it's ready for a substitution. It's going to be u squared minus 1, u squared minus 1, u to the 6th du. And you can see the entire method is driven by trying to pull out the derivative. I think the only way now is to expand. So this is ultimately a big algebra arithmetic problem. Plus 1 times u to the 6th. It's going to be the integral of u to the 10th. Now a common error would be to do your exponents wrong. But you've done that a lot this term. And that's something you could double check. Meaning if you factor out u to the 6th, you could see what you got. But let me not, I've already probably spent too long here. Plus c, and then you replace this with u. So let's do two things. Peek at the solutions. 1/11, 2/9, 1/7. Great. Then let's look at a common error. So I'm grabbing a random one here. So it appears to me that this student, they just immediately started using identities. So they had a misunderstanding of the goals. All right, the first step is either you're doing a half angle identity, and that's if it's even, or you're pulling out the derivative. So they did not pull out anything to start with. They just started randomly applying identities. And so if you're in that boat, it's just not going to work. You have to have the idea. So that's a preparation thing, I think, not so much a mathematical skill. Anyways, so in the next one, you should realize right away that it's a trig sub. There's a plus, so you should be doing 4 tangent. That should be almost automatic. And then you should be slowing yourself down, because the next few steps you want to make sure you get right, and they're common sources of error. So one thing that's going to happen is this is going to simplify. A few students I've said, if you don't see that there's a square root there, write it. Because I've seen some people have trouble simplifying the 3/2 power. And hopefully at this point in the term that's not troubling you in terms of simplifying. But anyways, you get this. And so you get 16 times tangent squared plus 1, which is really just secant squared. And that's the whole point, is this thing right here, the square root of this, is going to become 4 secant. So this is going to become 2 over 4 secant. That's where maybe it's helpful to write it as the square root cubed. But don't forget the dx. So it's 4 secant squared of theta d theta. You get 4 secant squared of theta d theta. So you need to be practicing these. These are on a lot of old tests. You should be practicing in a way that you're forcing yourself when you're doing these old tests to do some of these details and make sure you have the first steps right. These are gonna cancel. You're gonna have 1 over secant, which is actually cosine. And then it'll end with the triangle trick, so maybe I'll stop there. I grabbed just a random one that had some errors. So this student knew that it had something to do with tangent, but they wrote something that didn't make sense. They're misunderstanding the method. Then they had trouble simplifying, and they didn't plug in things correctly. So that's just knowing the routine. That's less a mathematical skill, and they just didn't know the method. People do pretty well on those two, but if you're someone that's making errors on these foundational problems, those are just hurting yourself. So you're losing points that you should be getting. Let's take a peek at the solutions if we save any more details I want to make. So you can see they didn't do some of the simplifying I did, but they got to the same place. There's that cosine. This is sine. They drew the triangle that went with this. So they wrote this as x over 4, opposite over adjacent. Solve for the other side, and then they wanted sine. Sine would be opposite over hypotenuse. There we go. Let's go back, look at page 2. Evaluate this integral. So this should jump out at you as an integration by parts. And it should also jump out at you that you have to choose the arctangent here. And this has to be everything else. So this becomes 1/2 x squared. This becomes 1 over x squared plus 1 dx. And then you do the substitution. After you do the substitution, you're going to end up with 1/2 x squared, arctangent of x from 0 to 1. And that evaluates nicely. I would evaluate it as I'm going. And what I remember the most from this exam was students getting stuck right here. And it appears that both of these, I grabbed a couple. This student got stuck right here. They didn't know they knew long division was important, but they didn't know how long division worked. They have the denominator in the wrong spot, the wrong conclusion, some problems with integrating. This student, it's just nice to see somebody else work. They did not know where to put this in the integration by parts. So they knew it was by parts, but they didn't know where things went. They gave an incorrect. You can't integrate that way. So your job is to think about how can I prevent that from happening. So I'm just trying to show you some examples of mistakes people have made. I think that this should be automatic, and that in my experience, this is where maybe students get stuck, but that division should also be automatic. Okay, this one, most importantly, is take a step and show that you know that this is a 2-step process. And then the challenge was that denominator. So at this point, the limit stuff is separate. We just need to show that we can integrate. So you're going to keep that out here. I would probably factor out a 3 This is x squared plus 2x plus 2. This is one of these where you try to factor this for a little bit, you realize you can't, and then you complete the square. So it's an irreducible quadratic. What I saw as I look at a random old exam, the student completed the square and didn't realize that they already knew this integral. They were done right here. They just needed to write arctangent of x plus 1, or do a substitution and then write it. But in not noticing that, they made a mistake here and they did not write this as secant squared. So this should have just been theta, and that messed up a bunch of other things. So this is a little bit lesser issue, but it was preventable. Irreducible quadratics always lead to this arctangent. Anyways, let's take a look at the solutions for that page. So there we go. That's that simplification I was talking about. You can see how short this was. You did have to remember that limit, but okay. So there's a couple pages on integrals. So we had a trig sub, by parts, partial fraction, sort of, even though there wasn't a lot of partial fraction work going on. Then we have one of these tomato dropping problems. You have the tall building. There's some window. They tell you this is 320 feet. 2 seconds after it passes your window, it hits the ground. So they don't tell you this time. And they don't tell you this time. They just tell you that this is 2 seconds. That should immediately make you think, oh yeah, that's that homework question we did. Now my personal preference was to always make the top 0. And the fact that they told you it was dropped told you this was 0. And you should immediately, when you see this problem, write the acceleration is negative 32. The velocity is negative 32t plus c. And the height is negative 16t squared plus c. So that should be automatic. You want to get those points no matter what. Then you should be putting in your information. So if they say v of 0 is 0, this should be 0. The moment you do that, you're making an assumption that the top is 0, but that's an assumption you should make. So this is the same question from the homework, which was, okay, we have one more unknown, but we unfortunately have this other unknown. And the big bit of advice is to label your unknowns. And in this case, I would label this, whatever you want. How about I don't know if I should label it lowercase a, but I'll do it. Let's call that a. This is going to be a plus 2. That was the main observation that you had to make. What they're telling you is that h of a, I did this in class and we talked about this, it's just been a while, and h of a plus 2 is 0 because we're at the ground. And then the rest of the problem is just plugging that in. Meaning, if you plug in an a for t, we already know c is 0, plus d, this is 320. And if you plug in an a plus 2, this is 0. And then we're basically done. I find that there's too many people that are worried. At this point, you have 2 equations, 2 unknowns. You should be able to simplify and solve. However you want to do it. So, but the simplest way is to solve for one variable. So let's solve for this one. This is 320. I shouldn't say simplest. The least thinking method. And then we're going to combine them, and so that we get one equation. You just don't want to be scared by a little bit of algebra like this. So I substituted. And now we have one variable, so now I'm going to expand and see what happens. Plus 4a plus 4 plus 320 plus 16a squared. The 16a squareds are going to cancel. I think this ends up being negative 64a. Negative 64 plus 320 is 0. Let's double check there. Oh, they did it a very different way than what I would do. I think that's way more complicated. They still labeled the unknown. So they're doing the same idea in principle, but they wrote it in terms of integrals. I would never do it that way. It's just a matter of taste. But anyways, you can solve for A here and get it. But just to look at a student solutions, when I look at the student solution right away, they're doing okay at the start. But then right here, they assume that when the time is 2, so they misread the question. They assume that t equals 2 is when it was here, which is does not what the question says. So they lost a lot of points. Anyways, then we have a graphical question. I just wanted to throw this. I grabbed this exam partially for this question because it's often something that scares people. You just go, all right, it's the derivative. It's the fundamental theorem of calculus part 1. Don't let the fact that if you're going to in a table, and now we need the derivative of the square root, which is this. Don't let that scare you. Just write it down, then plug in a 9 like it says. And if we plug in a 9 to that, we're going to get f of 3, square root of 9, times 1 over 2 times 3. F of 3, this function is f. So f of 3 is the height at 3, which is 4. So this is just 4. So this whole thing should be 4 over 6, which is 2/3. So I think people just panic when they see this. This student did remember to plug it in, but they forgot the chain rule. This student over here, they did the chain rule. They plugged in a 9, but they changed a multiplication into an addition. So I think sometimes just when things look different or symbolic, there's a little bit of a freak out about it. But anyway, this is the definition of the derivative. When you see this, you should immediately be saying delta x b minus a. So sometimes we use these questions. You don't have to know anything about the graph, really. But we use these questions to test this little a bit. So this means b minus a is 6. But what bothers us about that, this is kind of interesting. I hadn't looked at this ahead of time. Maybe I didn't do it this quarter. Is this is not, doesn't look like 6i over n. So there's 2 fixes to that. We could go back and call this a 3 and factor out a 2. That's probably the easiest solution. Or the other solution is to realize that this right here is a half of that. So 2 solutions here. You could think of this as f of 1/2 of the tick mark times the thickness. Or you could think about this as being 2 times 3, in which case b minus a is 3. But I'm probably just adding confusion there. Either way, so let's go back. So the main thing that bugs me in this problem is there's 2 things I should be looking for. I should be looking for the width, and I should be looking for the tick marks. The tick marks should look like this. So the moment you decide whatever the width is, what should bother you is that I don't see I times. So now I would go back. I guess that's the challenge here. And I would say, well, it looks to me like this is 3 over n when I look inside. So I would really like this to be 3 over n. In which case we can conclude that b minus a is 3. And we'll factor this 2 out, so we'll write it as 2 times the sum of f of I times delta x times delta x. Now, the thing that's being added to I plus delta x is 0, because there's nothing being added here, which means b has to be 3. So at this point, I'm going to say the integral from 0 to 3 of f of xi, so f of x dx. So that was the main point of that. And then that's area. So that would be, the area of this is 1 by 2, so that's 2. And the area of this is 2 by 2, so that's 4. And the area of this is 1/4 of a circle of radius 2. Pi times 2, so it's pi. So it's 6 plus pi. So this is 6 plus pi. But the main question was this translation step. This one should jump out at you as a substitution problem. Again, I think sometimes these symbolic problems just make people freak out, but actually in some ways it makes it easier because you have less calculation to do. So we get x dx is 1/2 du. The 3 becomes, let's see, a 9 minus, so it becomes a -1. And the 4 becomes a 6. It's going to be 16 minus 10. And then this is going to become 1/2 f of u du. So this is 1/2 of the area from -1 to 6. So now you would find the area from -1 to 6. So this altogether is 4. This altogether is pi plus 4. And then these two things are going to cancel right here, positive and negative. So the only thing that's left is that trapezoid, which you can do in a couple different ways, but it's 4 by 2 by 1. So 4 plus 2 times 1 times 1/2. So that's 3. So anyways, this whole thing is 1/2 4 plus 4 plus pi plus 3. Let's take a look. One half of 11 pi. This was 12 plus 2 pi. Yeah, they factored out that 2. Let's go back and look. Oh yeah, I forgot my 2. So it should have been 2 times this. Okay, average value is 1 over 2. 3 minus 1. Didn't go from 1 to 3 of f of x dx. So it's 1/2, and then it's just the area from 1 to 3, which we already know is pi plus 4. So there seems to be something in these questions that students think they have to find a formula or they want to find a formula, but that would make it much worse. So there's some errors here. This person didn't attempt anything. Got to try a substitution here. This student tried to find the equation for the function and tried to integrate. If it's a graphical question, you're not going to play that game. Same thing here. They didn't know what to do here. These are on enough old exams that we should have an idea. And then same thing. They tried to use the function. Now, a lot of students got those things right, but it appears there's a couple common errors, and hopefully you learn something from former students' errors. Okay, let's keep going. The region in the xy plane that is above the x-axis and below this line. So I'm going to start drawing because they gave me enough information. Below this curve, in between x equals 1 and x equals 4. So the moment I see this, I go, I would like to use x is rotated around the line y equals -3. So a recap of the thinking is choose your variable. We'd really like to use x. The good news here is using x gives exactly what they want, which is washers. It's perpendicular to the axis of rotation. You should realize right away that that gives a washer. And this was that cross-sectional area method. So if you forgot, it's 1 to 4 of the cross-sectional area with respect to x dx. And then your job is to find that formula. But in this case, it's a washer, so it's pi minus pi. That's all stuff you can really do automatically. Now your job is to figure out the inner radius, which is 3. And the outer radius, which is 3 plus the function. And I just like to turn everything into a positive number and think about distances. That did ask us to evaluate, but I think I'm not going to talk about that in this part. Then use shells for the volume of this solid. So shells is not the way we would like to do it, but this question is asking you just to see if you can set up. The reason we don't want to do it with shells is because we're going to have to split it up. But if you're just setting up, it's not quite so bad. So let's do a few things. If you plug in 1 to the square root, this function was the square root, you get 1. If you plug in 4, you get 2. So a few things. This should be at 1. This should be at 2. I'm just starting to get things in terms of y. And that's the problem. When you get above 1, the patterns change. So my first thought would be, oh shoot, I've got to split it up from 0 to 1, and then 1 to 2. And since I'm doing shells, it's this. I should have said something. But really, part A tells us this. We should know that we're using the variable y if we're doing shells. We just did a washer problem. So we should be thinking about this. And the reason I'm saying there's two different patterns is because there's a different pattern. For the left side, you can see it. X equals something here and X equals something else here. So we did a lot of this. Go back and review. But this is what you should be filling in. The radius is going to be y plus 3 for both of these. That's how far. If this is 3, that's how far this shell would be. You give me a y, it's going to be y plus 3. The height is going to change. So here it's going to be 4 to 1, so it's going to be 3. This is 3, and that's going to be true from 0 to 1. But from 1 to 2, it's going to be x equals 4 on the right, and x equals y squared on the left. So it's going to be 4 minus y squared. I know it's y squared because y was the square root of x. That was our setup. Something like this you could actually compute if you had time at the end of your test, which you probably will on a final, and see that you get the same answer. So it is something that's checkable. If we look at a mistake from a random student, they just assumed the in and out radius were constants. So they should have recognized something was off there. Excuse me. This student had some major... They got the height sort of right, but they didn't have the radius. The radius would never be y squared. And so hopefully I'm just kind of noting a few things. I don't know if you're gaining anything from seeing other students' errors. Then we have an arc length question. It's fairly direct. Okay, so we're going to take the derivative, which is going to be 2x e to the x squared. That's the chain rule. And then we're going to write the arc length. So we're going to do from 1 to 7, square root of 1 plus this squared. And since it looks like I'm going to do more with it, I probably would do the squaring right now to make my life easier. So that squared, I shouldn't draw it on there because you're going to might be confused by that. It's going to be 4x squared e to the 2x squared. If you don't know how I got that, squaring means two copies of the same thing. So what I did in my head was this times this. And then I rearranged the multiplication in a way I wanted. So anyways, that's what this is going to be. 4x squared e to the 2x squared dx. And then it says approximate with Simpson's rule. So you're going to do delta x is 7 minus 1 over 6, which is 1. x0 is 1. x2 is 2. All the way up to x6 is 6. And I don't like that question, but the next step, if you're doing Simpson's rule, is 1/3 times delta x, which is 1. And then what I should very clearly see is this expression. That's the function. Over and over again. So I should see the square root of 1 plus, and then we should be plugging in the first tick mark. And by and large, most students got that right, but I found kind of a typical mistake. See if you can spot it. So the student did part 1 correctly. They didn't simplify, but the question didn't require that. But then what did they do in part B? In part B, they wrote f of x was this. And then they used this formula. Formula's right, but the function's wrong. That's not f of x. F of x is always this. That's a pretty common mistake I see. And so they lost a few points there just because they were kind of blindly trying to use a formula. Okay, let's keep going. I have a pumping problem. We've now seen quite a few of these. Job 1 is to label a horizontal slice here and ask yourself, how much does that weigh and how much is it going to be lifted? So there's always this force component and this distance component. In this case, what does it say? This function is y equals x squared. So that's why you have to label this y. It's rotated around the y-axis to form a container. So it's rotated around. So the cross sections are circles. Distances are measured in feet. The work to pump the top to the top of the container. Okay, so you're pumping to the top of the container, so the distance lifted is going to be 3 minus y. That's this distance. So now the rest of the problem is the force, and they told us that that's 50 times the volume. And so then the rest of the problem is the volume, but the volume is going to be dy times the area. So as we've seen many times, it basically boils down to finding cross-sectional area. It feels a little bit like washers and discs, but it's not. And so here you would have a pi. On the test, students were always using pi even when it was a rectangle, but this, you know it's a circle because it's a revolution. And then you need one last thing, which is what is the pattern for how far it is from here to here. And you can't say x squared, you have to say x is the square root of y, because we're giving you a y. So there we go, we have it. The only thing left is the bounds. So the question is, what actually moved? What got lifted? If I give you y equals 0.5, it didn't move at all. If I give you y equals 2, it did move, it got lifted. So the bounds are 1 to 3. Then it's going to be 3 minus y, that's the distance, and then the force is 50 pi y dy. And that's actually not too bad computationally. So I was just trying to find examples of mistakes, and here was one I found. So this student tried to find the volume of the container. So it's kind of a misunderstanding. You're not going to find the volume of the container unless it asks for that. You need this combination of things. So they just threw the volume in here. So this student lost a lot of points because they did not put the things together. So anyways, I don't know if that's, like I said, I don't know if that's helpful. I'm just trying that. X coordinate of the center of mass. You should realize immediately you have two things to do. One is to compute the area, which is the integral from 0 to 2 of 1 over 9 minus x squared. And the other is you're going to compute this integral. Same thing, but with an x on top. So this was an integration problem. You need to compute this. You need to compute this. What I find, and I saw this as I was looking through, people that got this wrong were often kind of disorganized, or they wrote stuff they didn't need to write and got themselves confused. This person tried to do Trig Sub when there's a clear other method that you could use. This person incorrectly used a formula from the table. So it's something about the size of the computation. So this is more, I feel like someone who's organized is going to do better here, but you can factor the denominator. So this is a partial fractions problem. 3 minus x, 3 plus x, and then you should be doing partial fractions. Now, could Trig Sub work? Yes, but it's going to be much harder. So embrace partial fractions. Basically, this one you could do with regular substitution, or you could do with partial fractions because the numerator is x. You just calculate them. So I don't think I'm going to show that. Let's pull up the solutions. I think I haven't looked at it in a little bit. There's that revolution problem. There's this one we talked about. There's the approximation. There's the pumping. There's the partial fractions as you can see it. Okay, let's keep going. So then we get down to the last couple pages and we have a separate and integrate. So let's talk about that. This is separable. Square root 16 minus y squared dy equals x dx. We're going to integrate. Now this actually is in our table. It's arcsine. So if you ever were, you can also do Trig Sub. You can also do other things. But you might, before you dive in, we have used this a couple times. We've used this one a lot more. But this, I don't know why my pen decided to stop working. This happens every once in a while. I've never figured out why it does this sometimes. But anyways, it's arcsine of x over a. Worst case, you don't see that, and you have to do a few more steps. Arcsine of y over 4 equals 1/2 x squared plus c1. And so we get y over 4. And this is the stuff we've been doing lately, so maybe I won't say as much about this. People that got this wrong, let's see what happened. So this person made a really big mistake right here. They just assumed it was log. So that's a big careless mistake that loses a lot of points. Okay. Let's peek at the solution, see if there's anything special I want to say about that. Nope. Separate, integrate. You can take the sign on both sides. You can plug in the initial condition earlier, or you can wait. That's fine. Last one. So here's one where it's a population problem. A type of bacteria goes at a rate proportional to its population. So this is it. Now, normally when I've been writing it, I've been writing dy dt is ky, or dp dt is kp. But it's similar. We have dy dt is alpha y. So don't let other variables scare you. There's initial bacteria. So in this case, you don't even have to solve this because it's one we've already done. You can just write c e to the alpha t. Now if you forget, you end up solving. But they told us all the information. They said y of 0 is 12. So when you plug in 0, you get 12. That means that has to be 12. And after 2 days, there's 130. Okay, so it's 130 when this is 2. And so you're just going to solve. Divide by 12. 130 divided by 12 is e to the 2 alpha. Log of 130 over 12, which we can simplify if we'd like, is 2 alpha, and then you're going to divide. So that really was meant, the question maybe looked different. They actually solved, but it's the same thing. In this case, you could quote it just because we've done so much of this. That would save you 2 steps. But I have some memory of students complaining about this question. So the scientist now, after the first 2 days, starts harvesting 100 bacteria each day. So from now on, the differential equation is this. And we have talked about equations like, so it says now we have a new differential equation. We're going to use whatever that same alpha was, but we're removing 100 a day. But they tell you that. If alpha is the same, after how many days until there are 1,000 bacteria? So now we have to solve this. So we need to separate. So there's a situation, yeah, there's kind of a different story, but you just separate and solve. That's true of most of the application problems. So the truth is there's not a lot of setup. This is going to be the log alpha y minus 100. You have to remember to divide by 1 over alpha t plus c1. And then the rest is this house cleaning. And at the end, you're going to find when it equals 1,000. So let's peek at those solutions. So you can see there's just more work to do. It was the same collection of steps. Oh, they did it in 2 steps, but I normally would do that in 1. They plugged in their initial condition and they solved. The solving had some of its own challenges, but there you go. So that's it. When I look at errors, so the errors I saw on the first part here was simplification. Maybe not. Yeah, it was. That was just a missed copy, so that's not quite so bad. But this one, they didn't know what to do to solve. They didn't separate. So they missed that idea. Same thing with here. They just assumed they could use the model from the previous part. So if you get a new differential equation, you do have to solve it. So there we go. There's walking through another exam with a few discussions of some common errors. I'll make some timestamps, and hopefully that gives you yet another exam to study. I hope people get kind of lost in the details. After you study a test, scroll back through and ask yourself, how much of that could I have started immediately? And that'll help you maybe identify where your holes are. All right, hope that helps.